All right, let's look at an example of where one of these combinations of composition would come in like a real life example. It says a ship is moving at a speed of 30 kilometers per hour parallel to a straight shoreline. The ship is 6 kilometers from shore and it passes a lighthouse at noon. Express the distance s between the lighthouse and the ship as a function of d, the distance the ship has traveled since noon. That is to find f so that s equals f of d. Well, any of these types of problems, it's usually easier if we can draw a little picture. So I want you to pause the video, try doing a little sketch of this, and then we'll kind of proceed on. Okay, let's see how you did. You got some kind of shore, hopefully some kind of maybe like shoreline here. On the shore somewhere is a lighthouse. There's a ship going by this, or running parallel, so the ship's going to be running this way. At noon, it says the ship is, I'll draw my little ship here, right in, or passes that lighthouse at noon. And then we know that the distance is 6, so this distance right here is 6 kilometers. Express the distance s between the lighthouse and the ship. So let's make sure we get s on there. The ship sometime later is going to be out here. That's the distance s. So I'm going to call it s here. And then we have one more thing, and the ship as a function of d, the distance between, or distance the ship has traveled. So the distance the ship has traveled since noon, that's going to be right here, d. And what that's going to form here is a little right triangle that we have. The one other thing, we know that the speed is 30, so if you want to throw that on there too, that we're moving here at 30 kilometers per hour, we can put that on there too. All right, so that should hopefully help us a little bit. So what we have to come up with is s here. What is that distance s? Well, looking at here, if we got a right triangle, we know we got all the sides, we can use Pythagorean theorem to combine those together. So we know that s squared, the hypotenuse, equals 6 squared plus d squared here. So just solving for s here, we got 36 plus d squared. And then to get rid of that, we know we can square root here. And we don't need to worry about the negative answer because we're doing distance here. So s would be the square root of 36 plus d squared. So that right there would express s as a function of d. Another way of saying that here is that s, our function here, is a function of d. All right, express d as a function of t, the time that has elapsed since noon. So now what we need to do is how do we find d, how far the ship has gone? Well, the distance it travels right here will have to do with the speed and how much time has elapsed. So if you take how fast you're going and multiply by the time, that would come up with the distance. So how fast is our ship moving? We know 30. So 30 kilometers per hour times the number of hours t should give us that distance. And here, the distance is a function of time. So whatever time we plug in and the number of hours since noon, that should tell us the distance traveled. All right, last part of this one now. We know those two things are true, that s is a function of d and d is a function of t. What is s composed with d? So if we're going to do composition here, s composed with d, we're trying to find what is s composed with function d here. So what we want to do is take function d, take what that is, and place it inside here to find the composition. So that would be 30t squared plus 36. So our composition here will end up being, if we square both of those things, 30 squared is going to be 900t squared plus 36. What does this function do now? Well, this is now a function s that is now only dependent on the time. Time is the only variable. So what this can tell us is this will find the distance from the lighthouse to the ship by plugging in the time. So as a function of the time in hours since noon. So if you just know how many hours have elapsed, say 6 hours of or 7 hours have elapsed, just plug in 7 for t and it'll tell you how far that ship is now in a direct line away from that lighthouse.